Good morning, class. I am Miss Kasuga, and with me are my co-teachers for today, Sir Ramos and Miss Haranilia. Today we are going to be tackling the concept and types of charging. But before that, let's have a little recap. We all know that matter is everywhere. It is everything that occupies space and has mass. Thus, almost everything is a form of matter that is made up of atoms. These atoms have three basic components: the protons, which are positively charged particles, the neutrons, which have no charge and are neutral, and lastly, the electrons, which are negatively charged particles. Unlike protons and neutrons, which are held firm, electrons are held loose, thus they can transfer from one atom to another. How objects hold electrons varies depending on its materials. When an object loses electrons, it is said to be positively charged, in contrast to gaining electrons which are negatively charged, which leads us to our topic for today, the types of charging.
Hello, I am Sir Ramos and I will be explaining to you charging by friction. But first, what is friction? Friction is a force that resists the slipping of an object with another object. It can be done through the process of rubbing, and it increases due to more contact. I will show you charging by friction in this simple experiment called the pencil and the rice friction experiment. And in this experiment, you will need a funnel, a plastic bottle, a pencil, and lastly, grains of rice.
The objective of the pencil and rice friction experiment is to lift the bottle filled with rice into the air and to show charging by friction. For the procedure of this experiment, first, we need to fill the bottle with rice using the funnel. Then, after it has been filled up, we shove the pencil through and tap the bottle filled with rice into the table. Then lastly, we lift it up. The reason why this happened is because friction caused the bottle to be lifted up. By tapping the bottle into the table and stabbing into the rice with a pencil, the grains of rice compacted and the air is getting out of the container, which made the friction between each grain and the materials around it increase. And as contact increases between two surfaces, the friction becomes greater. By shoving the air away through the stabs of the pencil, the rice grains cling to the pencil and in time, it will grab the whole thing. In a detailed sense, the rice grains generate friction on the body of the pencil. This means that it lost electrons, making it positively charged, and the pencil, made out of wood, garners more electrons, making it negatively charged. As per the law of electrostatic, opposites attract, thus lifting the bottle into the air.
Hello everyone, I'm Miss Miles Andre M. Kasuga, and for today I'll be explaining charging by conduction. Charging by conduction in its simplest definition involves the contact of a positively or negatively charged object to a neutral object. For the experiment, we'll be needing aluminum foil, a jar, a copper wire, a tissue, and an acetate paper. Later on the experiment, we'll be observing charging by conduction.
First, let's make a cover for the glass jar. Using the acetate paper, draw a circle that is bigger than the hole of the glass jar. After you draw the circle, cut it using scissors. Create a hole to the center of the cover using the copper wire. Then make a hook at the bottom of the copper wire. After that, cut 2 strips of aluminum foil. Using the scotch tape, secure the copper wire to the center of the cover. Then put the aluminum foil strips on the copper wire. To start the experiment, using tissue paper, rub it against the acetate paper. After rubbing it, observe what will happen to the aluminum foil strips when acetate paper touch the copper wire. When we rub the tissue paper to the acetate paper, electrons move from the tissue to the acetate. In other words, acetate paper gained electrons, making it to be a negatively charged object. On the other hand, the tissue paper loses electrons. That's why it becomes a positively charged object. When we touch the wire using the charged acetate paper, we can observe that the aluminum foil strips repel from each other. How does that happen? As I've said earlier, charging by conduction involves contact between a charged object to a neutral object. When our charged object, which is the acetate, touches our neutral object, repulsion between the foil strips can be observed. And by using the law of charges, we knew that they have the same charges.
Hi, I'm Miss Eliza Hernilia and I will be explaining charging by induction. Charging by induction is charging an object without actually touching it to another object. For this experiment, you will only need three things: a ruler, wool, and bits of paper. Our objective in this simple experiment is to observe charging by induction.
First, rub the wool and the ruler together. Then put the ruler above the bits of paper and see what will happen. When I rubbed the wool to the ruler gained electrons from the wool. The ruler became negatively charged while the wool became positively charged. Since the ruler is now charged, the bits of paper were attracted to the ruler because it is electrically neutral. Although the bits of paper is not a conductor, the charges within it are not free to move. The negative charges have enough mobility which causes them to be repelled by the ruler. This leaves a net positive charge on the parts of the paper bits nearest the ruler, and the ruler attracts the paper bits that go up and stick to the ruler.
Hope you learned something from this video. Thank you for watching!